So in this problem, you're given 4 different values for the variable called v. So v is a quantity, think of it as a placeholder, right, that we can put a number into. It's like a slot. We can put a number into a slot. And if I put these various values of v into the v slot in this equation, do we find that those values are solutions? So somebody that worked problem 6, in order of -2, -7, 9, and 8, what were your yeses and nos? So this was the way that you filled in this table. So let me cue in on just 2 of the examples. Let's look at v equals -7 and v equals +8. So for v equals -7, why did you say that it was not a solution to this equation? What did you do there? Anyone? Right side wasn't equal to the left side. All right, so let's see how that bears out. So here's my recommendation. Anytime you're plugging, mathematicians hate to use the phrase plugging in, but I'm going to use it for today because, what we're doing is we're taking the value -7 and we're substituting, is the word that mathematicians prefer, substituting that value in for v. So here's how I recommend you do that. Take the variable v and just replace it with an empty set of parentheses. This is called the parentheses skeleton. Make this your first step. There's some really good reasons for why we do this. One of the reasons I think you might appreciate pretty quickly, when we substitute the value -7 into this empty set of parentheses. So if I put this down here with a -7 in it, now our task is to figure out whether the left-hand side of this equation has the same numerical value as the right-hand side of this equation. Well, left-hand side, there's nothing for us to do. It's just -67. So the right-hand side, I have to simplify this. How do I simplify 5 minus 9 parentheses -7? What's my first step there? Right-hand side, we see subtraction, because it's literally written right here, 5 minus. But you're also seeing multiplication where? Yeah. So parentheses, another purpose that parentheses serve is it allows us to juxtapose 2 quantities right next to one another. Just write them one next to another and infer an operation between those 2 quantities, right? If I just write 9 and -7 next to one another like this, I don't know whether that little minus there means to subtract or whether I mean that that's -7 and I'm just trying to stick those 2 things together and multiply. So parentheses are a way for us to write those 2 quantities next to one another and imply that there is a multiplication sign in between them. So that's why we have both of those operations, subtraction and multiplication, on the right-hand side of this equation. So now that we know that we have 2 different types of arithmetic, what should we immediately be thinking about? Because? Yeah, exactly. Anytime we have more than one type of arithmetic, order of operations should be your first thought. Because again, if we were to read this from left to right, we would say 5 minus 9. Oh, let me do 5 minus 9. When in fact the operation which precedes it comes second in the expression. And according to the order of operations, that's what we have to do first. So order of operations tells us to do the multiplication that we see here first. So how do we carry out this multiplication? How do we understand, first of all, what is being multiplied here? This is a tricky thing to tease out. So we've got a -7 on the one hand, and we have, well, we can kind of see it in one of 2 different ways. We can see it as a +9 multiplied by a -7, which is then subtracted from 5. Or, as you were saying, we could see it as a -9 multiplied by a -7, but then what would I do with that product? Would I subtract it from 5? I would add it from 5. Right, so we have 2 ways of understanding this, and this is kind of, dropping a negative sign is probably the most common error to make in all of algebra and arithmetic. Not even professional mathematicians and physicists are immune to dropping negative signs at some point or another. So we have kind of 2 options for how to see this. We can either think of it as, this is, by the way, I prefer to think about it, but this is in my own thinking. Think of it as 9 times -7, and then I subtract it. And what's 9 times -7? -63. So then I would be subtracting negative 63. Or the other way for us to think about it is to turn this subtraction into addition. But if I trade subtraction for addition, I have to trade this negative 9 here for, sorry, the 9 in front of it for an opposite. So think of subtraction as addition of the opposite. And in that case, what I would be doing is I would be adding negative 9 times negative 7. And what's negative 9 times negative 7? Positive 63, right. So we have to pick one of these roads or the other. They both lead to the same destination. That's the good news. So we can think about this as subtracting negative 63, or we can think about it as adding positive 63. Those two are both the same thing. Just make sure that you don't count one negative sign too many or one negative sign too few and end up either subtracting 63 or adding negative 63, because that's the opposite of what we actually end up wanting to do. So I don't know that I can tell you for you which one of these two methods is the one that will stick best, but it's definitely something that at this point in the semester is worth spending some extra time thinking about. I'm going to take the path that was listed on the right and multiply 9 times negative 7 and get negative 63. And then my job would be to subtract negative 63 from 5. But what does it mean to subtract negative 63? As we were saying a moment ago, it's the same as adding how much? Right. Subtracting a negative quantity is the same as adding its opposite, which is a positive quantity. Right? So minus negative 63 is the same as plus 63. And now that all of our multiplication and division is done, we can do the addition. And the right-hand side of my equation is 68. So what's the meaning of this calculation? Now that we did all this work, what do we conclude from this?
That's not the value of v.
Yeah, right. That value of v doesn't, in fact, solve the equation that we were given. Because if it did solve the equation, both sides of this thing would have to be equal to one another. And they're not. I think we can agree, without too much controversy, that negative 67 is not equal to positive 68. Let's take that on faith. Those two are different numbers. And since they're different numbers, this equation doesn't balance when v is equal to negative 7. So when v is equal to 8, what changes? 5 minus 9. And then again, empty set of parentheses for my v, which this time we get to fill in with an 8. So how do I evaluate the quantity on the right-hand side? What do I do first? Multiplication. And what am I multiplying? 9 times 8, which is positive 72. And then I have 5 minus positive 72. How do I know, by the way, and I agree with you, that's negative 67, but this step is also worth thinking about for a minute. One of the biggest sources of arithmetic error that happens at this level is forgetting how to add or subtract numbers that have different signs. So here I'm taking 5 minus 72, and my answer, first of all, why is my answer to that subtraction problem negative? How can I know that 5 minus 72 is going to be a negative number?
Because a positive times a negative is a negative.
A positive times a negative is a negative. But I'm not timesing anything at this last step.
All right.
I'm subtracting. I'm not multiplying.
It carries the sign of the number at the highest value.
Yes, right. So the overarching principle that can tell us what the sign of an addition or subtraction problem answer is that it carries the sign of the number that has the bigger value. That was very precisely stated, yes. So between 5 and 72, the number which is further away from 0 is going to be the one whose sign is represented in the final answer. So 72 is much further away from 0 than 5 is. And since 72 is being subtracted in this problem, that minus carries through as a negative sign in our final answer. By the way, and how do we know this is 67 and not, let's say, 77? how come the values of these two numbers ended up subtracting instead of adding? Because sometimes when you do something like, I don't know, let's say I do negative 12 minus 10. What is that? So the trick here is that the values, 72 and 5, subtracted in this example down here because the 5 and the 72 had opposite signs. Right? Here the 5 was positive, the 72 was negative. So opposite signs subtract the value. Whereas in the example in the upper right of the screen, negative 12 minus 10, both of my summands here were negative. Same signs. And so the values add. If there's one thing that wouldn't hurt at this point in the course, it would be to give yourself a lot of practice and a lot of time to sit with the process of adding and subtracting numbers that have different signs. Okay? Or sometimes the same sign. Particularly just getting negative numbers into your addition and subtraction lexicon and getting some familiarity with how all that works, because that is a major source of arithmetic error. And in this class, I would really much rather we spend time working on your algebra work than to spend a lot of time working on your arithmetic. The nice thing about ALEKS is that it can help you work with the arithmetic along the way as well. It puts in all the prerequisite arithmetic topics, and if it thinks that you're struggling with this kind of stuff, it'll often add in an arithmetic topic to refresh you along the way, just to make sure that you're there. But spending a little time now can be really beneficial down the line.